Welcome to the first lecture of web engineering. Okay, the first question was already answered. Should the lecture be in German or English? And we will do English. For me, both is okay. If I talk too fast, too slow, or you don't understand anything, just ask me. So a little bit about me. First and foremost, some of you already had the honor to be, in German you say duzt. I'm not Dr. Michael Lesniak or Mr. Lesniak, I'm Michael. And if it's okay for you, I will also call you by your first name. A bit about my background. I studied computer science at the TU Clausthal here in Germany. Made my diploma thesis about semantic web and so on in Trento, Italy. Was a researcher at Daimler in Berlin, then here at Claudia Fore in Kassel, where I did my PhD about parallel programming. Might even be the case that some of you heard some lectures of me. Okay, head shaking, no one. Okay. And then, well, I said, okay, enough academics. I want to do a bit more real world stuff. That's why I became a software developer at Micromata, just out of curiosity. Who knows Micromata from some reason? That's incredible. And I've done projects in a lot of different fields, that is logistics, healthcare, automotive, and so on. Currently, I'm quite active in the area of big data and machine learning, that is working with really a lot of data, that is hundreds of terabytes, and processing them, analyzing them, and so on. And I'm working at Micromata in quite different roles as a software developer, of course, that's why I'm here giving the lecture, as a software architect, technical consultant for our customers, as a troubleshooter when there are performance problems and so on. So I have quite a lot of experience in different areas. And I've also developed really small applications, let's say for 5 users, which nevertheless generate a lot of money, or really large applications with 2 million and more transactions per day. So I hope I have a bit of experience to tell you a lot of really interesting things. First and foremost, I'm a huge fan of agile development and iterative improvement. That is, give me feedback. Either you can do it by email, which is not stated there, but probably on a later slide. But I've also developed a feedback application, which you can see. Okay, there you see a feedback application where you can enter any kind of feedback. You can send it, I will receive a mail, and it's fully anonymous. That is, I don't have any means of finding out who sent me an email. So I'm actually sent me nice things, but I'm also quite happy if you send me any criticism, hopefully constructive one. That is, if the lecture is, which you also can't read, which would be kind of feedback. Here, I can't read your slides. If it's too hard, if it's too easy, if I'm talking too fast, or if the content is presented too fast, if you're really bored, or if you have any other suggestion, just tell me so. And that does not mean I will change anything, but at least I will hear about it and hopefully maybe change some things. Okay, so first and foremost, what's the motivation? What are the goals? I've interviewed quite a lot of students, which, was heißt denn bewerben auf Englisch? Thank you. Which apply for different positions we have, that is for student positions or for software developer and so on. And when I asked them, okay, and what have you done? Do you have any real world projects? Can you show me some of your code, for example? Most of them honestly have to say, sorry, well, you know, bachelor, master, I don't have time for programming and I can't show you any real world project. I have done some really small toy examples, which, to be honest, does not contain much information if I take a review at it. So one of the goals is to develop a reference web project. What web project means, I will show you on a later slide, which is full stack. That is, you will have a backend, you will have also to develop a front end. It will be deployed online, and in my opinion, it's quite fortunate that you can also put your code online after I've reviewed it, so that now other students can take a look at it. And what I usually do is that when I review your code for giving your grade, I will each of you and I will give each of you the top 3 improvements you can make to your code, which is quite cool because then you can have the low-hanging fruits and you can improve your code and you can show it online. And when you apply to any jobs, you can show the code. So what are you going to learn here? Real world knowledge. This is not a theoretical lecture where I will talk for 90 minutes and then you will do some sort of paper stuff. It's about things I've learned, things I think are important, about best practices in the industry, and you will also learning to, well, do a lot of stuff. Learning to learn is, I think, the most important one, at least for a software developer. That is, the topics are, okay, you can't read it at all, can you? No. Okay. So you will develop a web application. That is, you have some kind of front end which the user uses in the browser. You will develop the back end. And of course, web application means the user has to be online to access it. So we won't do any offline stuff and so on. And we will cover a lot of different topics. So I know the lecture will be really hard. There will be a lot of stuff to do, but you also have the chance to learn really a lot. We will talk about architecture of web applications. That is, okay, how can you model your applications? How can you define the communication between front end and back end? What about security, logging, monitoring, deployment, and so on? We will develop the backend in Java with Spring Boot as a technology. We will talk about object relational mapping, about, what's the other one? Dependency injection. And we will also take a look behind the scenes. So you will all implement, for example, your own ORM. You will implement your own DI. Then, okay, this is the backend. This is where all the magic happens, but you also want to show your application to the user. This is a part of the front end, where we'll dive into JavaScript, especially JavaScript 6, ECMAScript 6. We will implement our front end with React and Redux. We will learn about HTML5, cascading style sheets, and so on. So at least this is quite a lot of stuff. But we will also talk about how can you deploy your application, how can you put it online. We will use Heroku for it for a number of reasons, which I'll state later. We will use Docker. We talk about continuous integration, continuous deployment. So how can you make sure that your application runs on your local development machine, on your integrated test system, but also in production on at your customer side. We will, of course, talk about handling databases and so on. Then on the more theoretical side, we will talk about HTTP, JSON, XML, all the protocols you need to communicate between different parts of your application. And last but not least, we will also talk a lot about tools, which are, in my opinion, also quite important. That is, we will talk about Git flow, about profiling your application for performance, about debugging your application. So, as I've said, a lot of topics for, I think we have 13 or 14 lectures, but we also have the exercises, which are, in my opinion, really, really important, because if you just listen to what I'm saying, it might be quite difficult to finish a project, and also you won't learn anything. So the lecture goals, the meta goals, are in particular to learning to learn, learning to research, to experiment, to evaluate. You will see in the first exercises, at least if you have a laptop here, sorry, I should have mentioned that, that I do not explain everything. I think it's not my job to show you some API documentation. You can read it by yourself when you need it. Because as a software developer, usually you don't understand everything 100%, which is also quite unrealistic. So you use the 80% that you need for developing your application. Yeah, by the way, if you have any questions, just shout it in German and English. A bit Italian might also work, so just tell me something if you have any remarks. Okay. Software development, this is a really strong point, at least in my opinion. Often there is more than one way to solve a problem, and the solutions are also quite subjective. And nearly all solutions have trade-offs. That is, if I'm choosing this framework, implicitly, I'm not choosing all the other ones. So I might have some advantages, but I also have a lot of disadvantages. And this is from my personal experience. Given enough time, every framework, concept, and approach is use whatever square word you want to insert there. That is, all frameworks are shit in the end. And I think the idea of the lecture is to give you some ideas, not truth that will hold for all the time. In particular, as we will see in the front end, the ideas, frameworks, and concepts that you will learn in this lecture will be, let's be honest, totally obsolete next year. The front end is developing really fast. So we will focus on the back end. because the ideas there are usually prone to stay a lot longer. But of course, you will also develop front-end. And do not forget, whatever I tell you, your lecturer might even be wrong. So sometimes there might be a better idea. Why not? Just tell me in the lecture or write me a feedback, either per mail or with a feedback application. Okay, now about communication. Now here, hopefully, is my email address. Yeah. General, I'm not a big fan of Moodle and so on for different reasons. So all communication questions, remarks, whatever you have, will be over GitHub under this link. I will also put all the slides and so on later all on GitHub. So one of the exercises later in the lecture will be to create or use your own GitHub account. And if you have something you want to say me in person, you can either do it by email or with the feedback application if you want to do it anonymous. Okay, so now, of course, you're all here to simply to learn a lot of stuff, but you probably also want to pass the lecture. So there will be a programming project. It will be not a team effort. It will be a single person effort. Project details will be around the middle of June, and you will also have then the time in the exercise to work on your project. So you can ask me questions, and I can give you already feedback. I can show you things to improve, and you will have time until somewhere in September. And you should use the time in the exercise because I will be on vacation for the whole of August. Okay, and just to give you an idea, the last lecture's project was a Twitter clone. So all students have to implement Twitter, improve Twitter because you could use 141 characters, which was really great. No, but the students learned a lot. Yeah, they learned to develop an application with a database connection, with authentication, user management. They had a really nice, some really great ideas for the front end, and every Twitter clone was put online. So you could show it to a potential customers, friends, family, and so on. And to live the idea of agile, iterative development, and so on, I'm still open for project ideas. I might have some ideas, but if you think, oh, I always wanted to implement some kind of Facebook in the small, for example, just drop me a mail or write me a feedback in the application and I will consider it. Okay, now the roadmap for today. Okay, usually all my lectures are structured more or less the same. That is, we talk about some organizational issues, which we already did today. Then from my experience, usually the feedback application is used to ask me questions. That might be questions from my practical work. That is, in the real world, how do software developers do this or that? And I usually answer this at the beginning of the lecture, some 4 to 10 questions, depending on the size. Then I will usually also talk about best practices. That is more or less disjunct to the lecture topics, but quite interesting. And in my opinion, these are all topics which are not discussed in any lecture at the University of Kassel, at least. So it might be quite interesting. And then we will usually review the exercise, the problems, the solutions you have, so that you have a wrap-up of what we're going to do next. Okay, so now what's the roadmap? First, I will demo the reference application. That is a application which will guide us through the whole lecture. This is kind of the goal where we want to end. And then we will have today write a fully complete backend application. That is, we will talk about the architecture, make a walkthrough through the code. That is, you will see a lot of code in this lecture. And finally, we will also deploy it online. And just don't be afraid. This will just be an overview. I will dive into all these topics much more deeply in the next lectures. But today is more about, okay, this is what we're going to do. Okay, it sounds nice. I will stay in this lecture, or maybe also, which is totally okay for me. Okay, not the type of stuff I want to learn. I will just leave the lecture. And finally, in the last 90 minutes, we will do the exercises. Where we'll just walk around and we can talk a lot about stuff. So, the reference application. Okay, the reference application is kind of let's say, a simple forum. It might become Stack Overflow. Who knows Stack Overflow here? Okay, so quite a lot. Some students do not. Stack Overflow is like a forum where you can ask programming questions, and the answers can be voted up and down. So the good answers are upvoted, and you can see the good answers first, and the guy or this girl who asks a question can accept one answer. And as a programmer, I would say it's one of the most important websites. And maybe this will become Stack Overflow, I'm still not sure, but this will more or less just be a work in progress as is stated here. It's simply a scribble to show where we want to go. So what is it from the functional component? It's a simple forum. We have topics users can comment on. We have users, we have authentication. I will show you a demo in a few minutes. And from the technical side of view, we have a modern backend with Spring Boot and a REST API. We have a single page application in the front end. We have authentication, and it's also deployed into the cloud. So I will just show you how it's looking and what. Don't stop recording. No, it works. Okay. Lecture demo Heroku. What was it? Heroku app. Okay, it should take at least 30 seconds to start. I will tell you later why. No, it won't. Okay. As I've stated, it's a demo app. That is, it does not look really nice, and you can probably guess a password if the username is M. Okay. Okay, so we have just some things to play with. We can click on a post. We see here some stuff. We can do some comments, blah, 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 blah. Can edit. We can quote comments. Let's quote this one, nice. And then it's written here, and we can say blah, 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 blah. And then you see it's quoted. We can write markdown, that is blah, 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 blah. And then we see here markdown. So you will learn to develop this application. We can add a new post, that is foo and var, really creative today. And okay, now we have two foos, whatever, it's from today. And this is the application which will guide us to all the lecture. Yeah. So any questions until now? So first and foremost, nothing happens. Yeah, something happens. Okay, let's take a look at a really meta look at the architecture of a modern web application. We will see other approaches to web applications which, depending on the context, might also work, might even be better. But I would say if you develop a web application today, this is usually the approach you use. And it might be totally obsolete in 2 years. That's the problem, but also the interesting stuff with software development. So we have some kind of backend. We have some kind of front end. They communicate over HTTP, JSON, JOT, and so on. From a technical side of view, here are all the technical functions like persistence with the database, the functional statements like in our reference application, storing the post, accessing comments, handling user management, validating user input, and so on. And in the front end, we have the user interface, the user experience is designed there, which is really an increasingly important topic, but not focus of the lecture. And in the next weeks, we will first focus on the backend until we have developed the backend, and then we will develop the front end. And the nice approach with this architecture style is that these things can be developed in parallel. Usually, this is also done. For example, in all projects we do at Micromata, it's done like this. We develop the backend, and we have a different team which develops the front end. We talk about the protocols here, and well, then we simply start. Okay. What is the next slide? Actually, I have no idea. Okay, so we will see here IntelliJ. I'm using Git as a version control system. Can you read it somehow? Pardon, it's possible? Sorry? Okay, so I can also, is this better? Okay. Oh my God. But it's better for you at least. Okay, so we'll start with an empty project. This folder that you see here, Documents Web Engineering 2017, is it's the same as, oh my God, it's the same as you will see here. So all the code that I'm showing you now is also stored here in the homepage of the lecture. Okay, so we will start with an empty project. We have nothing here. We have a README here which states, well, to do. So really not, and the slides, there is just the slides from the lecture. So really nothing of importance. And we will start, and I have to state it again so you won't be overwhelmed. I will dive into each of the topics. I will explain now much more deeper, but this is just a broad overview. Okay, we will add initial Maven files. That is, we now have some new files. We have a file called Pom Xml, whatever that means. And we have a file main. Can ich das weitermachen? Probably. Yeah. And we have a file main, which is probably a Java code. And we have this defined project structure. So let's take first a look at the Pom Xml. The Pom Xml is an XML-based file, as stated in the extension, which defines some meta information about the project, for example, the name, the version, and so on. And also the dependencies, because usually when you do software development, you're not developing everything by your own, but you're using libraries, you're using frameworks, and so on, as we will see. And all the frameworks are not some kind of magic, but if you have experience in Java, you can more or less, given enough time, develop them by yourself. So just out of curiosity, who knows Maven? Okay. So I would say at least half of you. And now we have this Pom Xml, which just states, okay, we have a Maven artifact called demo, which has this group ID and so on. More later. And now we have this directory structure, which is given by Maven. That is, we have here an approach called convention over configuration. That is, we don't have to define everything by ourselves, but some things are just defined by the tools we use, for example, Maven. And we have here a simple main file, which just states hello world. Let's try it out. Incredible. Okay, so now we have our Maven files, which is really boring. Okay, next step, or also one of the most important steps, the whole lecture is at least at the back end, is that we will use a kind of particular framework called Spring, or a better definition, Spring Boot it's called. That is, it's a framework with a lot of support for different stuff, but in particular we will use the libraries of Spring for web development. And what we do first is that we implement, that we add some params, that is, some definitions which are defined in another POM, let's say. Okay, nothing more has changed. Okay, quite boring. Now we will add the dependencies. As I've said earlier, we don't develop everything by ourselves, but we will use a lot of libraries, frameworks, and so on. And we will add dependencies here, in particular Spring Boot Starter Web. Okay, nothing else changed. So our main is still the same. So we can simply start it, and well, it's kind of boring because nothing else happened. And now some magic stuff happens. Okay, we will add some Spring code. That is, we have here an annotation, Spring Boot application, and we simply state, okay, now run our application. Let's see what happens when we run it now. Okay, a lot of more logging, a lot of things happening, and here is the, okay, the main application has started. We have some kind of application server listening on port 8080. What's going to happen when we just, oh my God, when we connect to 8080? Probably nothing. But we get some kind of message here. So we now have a web application with just a few lines of code, to be honest, doing nothing. But nevertheless, this is a web application. And what did we do? We have here our main method, which started it. And we have our POM, which just states, okay, use a lot of definitions from the parent here and use this dependency. So this is quite astonishing because in the earlier days, before Spring, for example, this was a lot of more complicated. Okay, what's the next thing? Okay, at least I've said it's really boring because, as you've seen here, it's just an error message. And I'm pretty sure you have quite a lot of questions until now. And if you might also ask them now, or you can write it in the feedback application if you want, or you can drop me a mail. But it's really important that you at least have a slight understanding of the meta concepts. You don't have to understand every bracket here and so on, but the general idea is really important. That is, okay, we have here some build system called Maven, which defines our frameworks that we use. And we have here a main method, which starts our application. And our application listens on the local host, that is this machine, on port 8080. Okay, now let's add some functionality. Oops. Okay, what happened now? Okay, so, okay. The only thing, as you can see here, or just a short notion, you can always see here are my commits from Git, and you see here all the files that have changed. So I'm usually, for this lecture, changing one file at a time so you can follow better. Okay, what have we done here? We can even make, it's really difficult to read because the screen is so small, but I think you can see what we did here. What did we change? We added this annotation REST controller, and we added a method called index, which returns a string, which simply creates a new date, returns it as a string. And then we have this annotation which states, okay, for all requests that go to localhost 8080 and given this path, use this method, call whatever is written there, and return it as a string. And if we start that code, it might become more interesting. Some questions? Sorry, any questions? Okay. Okay, yeah. Sorry. Yeah, you're right. Thank you. The REST controller is a meta annotation which states that everything in this class, and we will later refactor it and it becomes more clear, should be scanned for this annotation. And when we scan this annotation, we see, okay, we have definitions for particular endpoints, and it will be more clear in the later commits, and what code should be used. If we omit this, Spring does not know that in this class is a request mapping, so it won't be scanned and nothing happens. But we can check it out. Okay, first we started with this annotation, start our application. At this moment, yes, we will come to this later, or in the exercise. Okay, we started our application as stated here. Okay, it's still listening on 8080. And if I'm now going to this endpoint, I will see here, okay, something is happening, which is quite astonishing. So with just a few lines of code, this worked quite nice. And for instance, just to show you, blah plus, hopefully this should also work. Yeah. Okay, so, well, it works. And now, yep. Yeah, because it started as the web server started, and we will also see later how I can start it on the command line or deploy it to some other stuff, and it will also work. But until now, it started a web server which listens to requests, and until I stop this application, it will just continue to run. So every time I rerun the project, start the web server again, or? Yeah, because when I stop this project, the web server is stopped. It's so the web server is part of my Spring Boot application. Okay, now the question was, okay, what happens when I do not have this definition? And I will really kill and start it again. Yeah, if you use IntelliJ, just one small remark. If you do not have your single instance only checked, and you restart your project, yeah, the old project will still run and the port is already occupied, so the new one won't start. But okay, now, okay, we still have our project started. We do not have the REST control annotation here. And if I now do a refresh, okay, it's not working. So, but now, hopefully, even without a restart, no, I have to restart the application, whatever. Okay, so until now we have a, to be honest, quite bad, but nevertheless working web application. And if you remember, our goal is to develop this application, which looks really awesome, this application. So first and foremost, we want to store posts. That are the things we have here. We want to store some kind of title, the comments, and so on. So what should we do first? Okay, again, we're only editing this file. We will add some endpoint called post. And now what happened? Okay, is this better? Okay, what happened? What did we change? Okay, we still have our endpoint, but we changed the endpoint from slash to /post. We changed the return type from a simple string to a list of strings. Okay, we changed the name from index to get post list because that's what we want to do. And then we simply have a list of strings with posts and we return the posts. And by default, and this is also some type of string magic, which you will later implement by yourself in, well, let's say 4 to 6 weeks. If we start the application. What time is it? Super. Yeah. Okay, now something funny happened because I want to show you that I'm not. I also want to show you the mistakes I've made because normally, or usually, when you're on a lecture or you view some kind of YouTube stuff or something like that, everything works fine the first time. And well, this is not the real world. In the real world, for example, I just wrote this code and then I thought, okay, it does not compile because the diamond operator is not part of Java 6, and by default in your POM, if you don't define anything, it uses Java 6. So we will add Java 8 support in the POM. That is, we will define some properties here which are evaluated by the build plugin from Spring, so we can use Java 8 features. And if you do that, okay, it's not red anymore, we can start our project. Hopefully, yep. Okay, now we have an endpoint here called posts. Let's take a look what's happening. If we have our endpoint here, blah, 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 /posts. This actually looks great. We now have JSON returned and we can probably work with it. So not bad, at least we have a list of posts here. And of course I can add more posts which are always returned. Yeah. Okay, so we now have posts. Okay, what I'm not happy with posts being in this class. So let's refactor the post to its own date. Whoops. Oh yeah. Okay. Sorry. Let's refactor the post thing. Okay. What happened here? Okay. We simply moved the post list to an instant variable of the main class and return it. Okay. This is really boring, but let's do it. Okay. Now, as you see in here, we do not add anything to the linked list. So this should return an empty JSON array. Okay. Now, some simple stuff. That's also something we will dive in much more deeply in the later lectures. If you have API endpoints, for example, I want to access posts, you usually write it in singular, not in plural. That is, we simply move from post to post. But nevertheless, let's do it. Okay, and if we check now, post should return a 404. That is, okay, there is nothing there, and post should work. Okay. And now, okay, we have an empty list of posts, which is kind of boring. So let's add an endpoint for a new post. What do we do? We leave more or less everything the same, but we will add a new method. First with a more complex path. That is, we had here post, and now we have post add. And let's see what's happening here. Okay, we have post add here. Have a new method called add post. And have this funny looking annotation as part of the method's argument. That is request param title. Whatever that does, we will see it later in a few minutes. But this method, it seems at least, does get a title, and we add it to our data structure here. Okay, what's going to happen when we start it? Yeah. Actually, you will do it in the exercises, at least if you have the laptop here and so on, whatever. Okay. Okay, again it started, and now we have our list of posts. Okay, posts, we have here ads, we have set request param, whatever it is. I think it does something like that. Cool. And now we will switch tools. That is, okay, it's quite possible to use here Chrome to play around with the API, but to be honest, it's not very comfortable. So we use something like Postman. Okay, is it better? Yeah, that's better. Oh God, I have no idea how it should work if it's so small. Just give me a second. Oh. Huh. This is not good. Nope. Okay. Shit. Sorry. Okay, whatever. Okay, this should work. Post, add, and then we can have some kind of params, which is a bit more comfortable with this tool Postman, which you can just install in the Chrome App Store. You can also save your queries and so on, so we have a bit more comfort here. So let's say I will add a title footer, and you see here I have this nice UI, and if I added something here, it will be added at the URL. Then I can send it. I can see what headers no. I can see what is responded. I can see cookies. I can see the headers. I can write tests and so on, which we will also use later in the lecture. Okay, now I have added a post. Okay, I got no response, but let's say I will just want to view all posts. Now I have them here. So I can just test, send a request, send it here, and see, okay, now we have some kind of endpoint to retrieve our posts, but also to add them, which is kind of nice. So the next thing, okay, now our application becomes bigger and bigger and so on, and we don't want to use everything here in the same main class. So now we're going to refactor the controller logic. This is a REST controller here, into our own package and controller and so on. So we have this main class, and we also have the post controller. So what's happening in the main class? Okay, we remove everything. We simply start our application here. Okay, and then we have a post controller, which is a totally new class where we just moved everything from our main controller to our post controller. And if we do that, we can see here we also have a new package, and now some type of personal preference, but also at least somehow guided by experience. When you do packages in Java, you have two possibilities. You can structure them by functionality or by technical, by the technical structure. If we would have a technical structure, we would have a package controller, we would have a package services, we would have a package database, and so on. And in my personal opinion, and you remember the slide opinions, in my personal opinion, it's easier if you structure it by functionality. That is, everything from posts, for posts is in the post package. Everything for comments will be in the comments package, package and so on. Because usually when you add a feature or try to fix a bug and so on, it's about some not working functionality, and then it's much easier if everything which is necessary for this functionality is under the same package, because it's much easier to understand, to comprehend, and to debug. Okay, so we did not do much, but nevertheless, let's start the project again just to check that everything is still working. And of course, since it's just a data structure here in the post controller, and if I restart the application, all the posts I've done are of course lost. That is, if we now check, we have an empty array, and if I now send a request, okay, I again have one method. Yeah.
There's only one namespace for controllers in Spring Boot.
What do you mean namespace?
Yeah, so the post controller is responsible for the only post controller here.
Yeah.
It's not possible to add another one.
Yeah, of course. I can do something like blah blah. Let's say post foo controller, whatever that does. No, I don't want. Don't want to add it to Git. And of course, I can do something like that. I can do something like this here. That is, I can have additional controllers, which additional request mappings, which are then at the application start due to the REST controller mapping, all collected and then combined to define which method handles the request.
I think I need it in a different way. It is not possible to integrate multiple servers in one project. Or is it? Can I have multiple instances of Spring Boot server application in one project here?
This is about IntelliJ, but what do you mean with project? Because
later on, maybe I want to let communicate the services.
Yeah,
is it possible to run two server instances?
Yeah, of course. With different ports, or what?
Yes,
What?
and there I have to develop a different project for it. Because, or is it any possibility to tell, please start this server on this port and
Yeah.
another one on this port?
It definitely is. We will see it later. Actually, in this lecture, maybe 6 or 7 commits. Okay. Yeah, I will just remove that. So, okay. So what did we have now? We had some refactoring done, but still what's happening here now is that we mix handling requests, that is, what endpoints do we have, with logic, that is, adding posts, removing posts, listing posts, and so on. And usually you have some kind of different structure. That is, you have your controllers, but you also have services which serve the controllers. Again, we will dive much deeper into this topic later. So now add own service class for post. So what's going to happen here? We remove everything which directly accesses a data structure post and simply call methods of a so-called post service. I will talk later about the auto-wired. And have a post service class which encapsulates all the posts and simply provides two methods, namely to get all posts and to add a new post. So again, really small steps. And if we did that, okay, we now have a post controller and we have a post service. Okay, now back to this auto-wired. As I've stated, as I've showed you all the topics we are going to talk about, one of was dependency injection. As you've seen here, I do not create something like blah new post service, which you usually do in Java. But I stated that post service is a service. That is, an instance is automatically created by Spring, and I can simply inject it into the controller. Okay, now what's the big deal? The big deal is that, as we will also see in one of the later lectures, this is a really great feature. For instance, I can switch databases. I can say I have a post service here which connects to a database or something like that. And if I'm doing testing, that is, if I'm writing unit tests so on, I can simply define, I could define another post service for testing which does something totally different or always returns the same post or something like that. And when I start my unit tests, I can state, okay, we want to use this profile testing. And then another service is used, and the post controller is totally unaffected by that. And it looks a bit like magic, at least it did for me in the beginning. But in one of the later exercises, we will develop our own dependency injection framework just that I can show you it's really not difficult. It's about class path scanning, it's about reflection handling, it's about creating instances and singletons and so on. So it's really a complicated topic, but I think if you've implemented it by yourself, my reference implementation is maybe 250 lines of Java code. It's really great to see, okay, all these really interesting and magically looking features of Spring are just Java in the end. Okay, just to reset everything I did here. So now we will add some documentation because I think documentation is interesting. It's not much. Now we have here our HTTP endpoint for post-related HTTP requests. I'm not documentation fanatic. That is, I think this is really obvious what it does. Yeah, it's a request endpoint that just calls a service method. So what should I document there? At least now. If the program becomes complicated, much more complicated later, we'll see. Of course, it will be interesting. But what's more interesting is that I usually comment all my service methods because these are the methods which are used throughout the application. Maybe from a controller, but maybe also from other services. Okay, and now we will do something really cool. Okay, it does not look cool, but it is cool. We will add Swagger. Swagger is a really stupid name in my opinion, but nevertheless, it's a really great tool. Okay, we now have here our, who knows Swagger? Okay, three and a half. It's just some additional dependency here. And when I was testing it, I just have to use the correct version. And then I will just have to state something in the main class, that is to configure it. And now this is, bear with me, just ignore it for now. It's just some configuration for Swagger, and we will enable it. And if I'm now starting my application, and you remember we had Postman here. If I'm starting my application, yep. Okay, we still have our usual application. We do not have any post because we restarted it. We can add new things here. It's returned, but as you've seen here, it's quite difficult to understand all the different endpoints we have. We have post, we have post add. There are a lot of options we could usually use here: get, post, put, patch, delete, whatever all the stuff does. And where's my browser here? But we can also simply use Swagger, which automatically, that is this annotation here, enables Swagger, scans through all your application, reads all your controllers, parses all this information here, for example, request mapping, this is a post, okay, this is a request mapping for post add, reads all these return parameters, reads all these request parameters and so on, and generates documentation. For example, we have our post controller here, and we see all the options, all the methods we could use here. And we will see later that that's a bit too many here. But for now on, okay, you remember we had this get post thing, and you see here, okay, what's going to happen if it's okay. You see here what's going to happen here, and I can try it out all the time. It shows me the command line I could use to do it on the command line. Shows me the URL, the headers, and then the response I got. This UI is really great for exploring your application interface in the backend. And we also see, okay, I have here a post add, and it automatically scanned and saw that a title is a required parameter. That is, what's going actually to happen if I do not add a title to my add here. Localhost post add, but I do not add a title. Okay, then I will get an error message. Bad request, blah, required string parameter title is not present in that path. And it automatically scanned and saw the title is required. So I can enter some title here. I see the data type is a string. Its parameter type is in the query. And when I try it out, I can see what URL is generated. Okay, I do not get any response body, but I can now try again our normal post endpoint. And last but not least, where is it? Try it out. I'm totally blind here. Try it out. I can see that it's also returning this. So with Swagger, we can do a lot of API exploration, let's say, so to speak. Okay, now the last thing. I have my application. It's now developed, but I also want to store it online. Okay, let's do it like that. So, because we are going to develop web applications, I do not want to implement them just that they can run on my computer. So some type of provisioning to be able to store them online is necessary. And there are an immense number of technological solutions, of technological providers, name it DigitalOcean, Amazon with all the stuff Amazon has, or for example, Heroku and a multitude of others. And Heroku is one of my favorites, but I would just want to say a disclaimer. No? It's not about advertisement. I do not receive any money. I just made really good experiences with Heroku for lecturing because in particular, it's free when you want to use it as a student. And for instance, if you develop an application and you say, okay, it's really quite a nice application. I want to put it online, have some additional features for $7 per month. You can put it online. So which we'll later use, have databases. We can send emails. There are a lot of stuff we can use your application with. And what is really, really nice is the deployment process, because somehow you have to get from I have my code in Git to I want to have my application online. So what are you going to do? And this is the magic of Heroku, this particular feature. You push your code not to your usual repository, but to the Heroku repository. It builds the application and puts it online. And this is, in my opinion, quite a nice approach for different reasons that we will also see later. So let's do it. First and foremost, we have to add an additional file. And this file is really boring because it just states, okay, this is a web application. It should run on a port which is defined by Heroku and should use this jar. And when I started it, I just thought, okay, I forgot to say the jar will be in target because Maven will store it there. So if we do this on the command line, probably totally wrong here. Now this looks better. Yep. If we do this, Heroku, let's see where I can have it. Git push, no. Git push, Heroku master. If I push my code, hopefully it will just work. Let's see what's going to happen. It's readable? It's readable? Okay, thank you. Okay, and what's now happening is I'm just using Git, the usual Git command line tool to work with my code, and I'm a huge fan of the command line. And I push it to another origin. That is, if we take a look here, okay, Git remote, what remotes do we have? We have the usual remote on GitHub and the web engineering, but we also have an additional Git remote in Heroku. And oops. Now, okay, it got built. Okay, it saw, okay, it's a Java application. Let's use Java 1.8, Maven. Then it got built. And okay, in the end, it says, okay, we launched this application here. So let's try to start it. And what we will see after about 30 seconds. Oh, well, of course, because if you remember, what endpoints did we have? We had the endpoints post and post add. So let's try it out. We have an endpoint post. Well, not surprising. Add title gleich Heroku. Okay. So, okay. And now we have our application live. And all we did was develop our Spring Boot application, push it into Heroku. How it's done in detail, you will do in the exercises. And our application is online. So, since now most of the exercises today are a bit more extensive, the lecture is over now and you should do the exercises. I know it's a bit early, but there are quite a lot of stuff to do because, again, you will do all the stuff I did and some additional stuff. You will work on that. You will build upon the source code I already provided and implement additional features. That is, you will use correct methods for the REST backend. You will deploy your code to Heroku. You will also create an account on GitHub and so on. So until now, any questions? I mean, you probably have a lot of questions, I'm pretty sure, because there was a lot of stuff in a really short amount of time. But this is just to give you an overview. We will dive into each of the topics you saw. That is, okay, what is this request mapping about? Okay, HTTP, what does that actually mean? Okay, JSON, what's going to happen here? How does this Git stuff with Heroku work? We will dive into all these topics much more deeper. But for me, all lectures I attended as a student were quite boring when in the first 3 lectures, the lecturer talked about all the stuff you have to do before you can actually see your application. And here we now have an application which honestly does not do much yet. It will much more after your exercises, which is already online, which in my opinion is really great because it took, with all my talking, about half an hour from we have an empty project to, okay, something's deployed online, and while not maybe a perfect application, nevertheless, it can be used to store posts and to retrieve them. Okay, so in my opinion, you should go now to the GitHub page. That is here, blah, 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 GitHub Micromata Web Engineering 2017. Download the slides, which are in a PDF format. And then you have the exercises, and they are normally structured from not so difficult to a bit more difficult. And of course, you can ask me all the questions you want in German, in English, Italian, no, not Italian, and well, okay, dann mache ich das erstmal.